All right, I'm going to go through naming multivalent metals for those of you who are going to be gone today. It's pretty simple. It's pretty similar to the ionic stuff we did yesterday, so just a little review from yesterday with ionic compounds. All right, remember we have to use a metal that'll be bonded with a nonmetal. Non-metals are positive, non-metals are always negative. So this is super simple. I take something like calcium and chlorine. Remember, we changed the ending to I, so calcium chloride. Calcium is Ca plus 2, chlorine is Cl minus 1. So calcium chloride is simply CaCl2 after we cross our charges. Super simple, barely an inconvenience. The weird thing is when you start doing metals in the center section here. If you look at something like iron, iron has more than one charge. Iron can be a +2 or a +3, depending on the situation. So when we name these, we have to take into account the +2 or +3 aspect. We have to let the other people know what the charge of the metal is. All right? So the metals have multiple charges, but they're always positive. We just don't always know what they are. Sometimes we have to figure it out. The nonmetals continue to be negative, and they never change. So chlorine is always -1. Oxygen is always -2. Those never are different. We use a Roman numeral to indicate the charge. So, for example, iron, Roman numeral 3, oxide. Okay? Iron tells us the symbol is Fe. We know it's a +3 charge because that's what the Roman numeral is, right? Oxide, as always, is -2. Cross your charges. Fe2O3. Super simple, barely an inconvenience. It gets a little trickier when you're going the other way. So let's say I start with the symbol. Okay? SnI2. Well, if I look at my periodic table, I find that Sn is 10 and can have 2 possible charges. Okay? I don't know what it is, so I'm just going to write down 10 for the moment. And I know we'll need a Roman numeral. So look at the other half of this. I is iodine, so we call it iodide. And now we need to figure out what the Roman numeral is. Remember, compounds have to be neutral, so the positives and negatives have to balance. So I know that I is a -1, so if I multiply those together, that gives me a -2 for my negative side. That means it has to be a +2 on my positive side to balance it out. Since there's only one tin, it has to be a charge of +2, so we call it tin 2 iodide. Okay? I'm going to do another one, because I get that can be a little tricky. I know it involves math. Math is scary. Let's take a look, for example, copper, CuN2. Oh, I wrote that down wrong. Cu3N2. Okay. Cu copper. And again, if I look at my chart, I see that copper is in fact multivalent. It can be a 2 or a 1. N is nitrogen. So we name that nitride. And now I'll go through the same process again. What's my negative side? Well, N is -3. 2 times -3 equals -6. So my positive side has to be +6 to balance it out. I don't know what my charge is, but I have 3 of them. 6 divided by 3 will give me X. So that is 2. So we know that this is copper 2 nitride. Again, shouldn't be too bad. Let's do one more. PbO2. Okay. Pb for my periodic table, track it down. Lead. Lead can be a 2 or a 4. Just going to write down lead for right now. Leave a blank because I don't know what my Roman numeral is. O is oxygen, so we call that oxide. And I figure out my charges again. Oxygen is always a -2, 2 times negative 2 is negative 4. So this side has to be positive 4 to balance out. Lead 4 oxide, right? Since there's only 1 here, this has to be positive 4, so it all balances out. Hope this helps. If you need some more help, let me know.